We're going to continue on SQL, pick up right where we left off, including my bad math, and I'll go ahead and explain what I was trying to do last time, but I was screwing up the math on. But before we do that, let's make sure that we're right before our break here. We're right before our spring break, and I wanted to point out on our Gantt chart where you should be. So for the next 3 days, you should be implementing your phase 2 of your project. That gives you enough time to test and debug in those last 2 days with a little bit of overlap. And it also gives you one pad day down here on Friday to either get it done before the break so that you can head out with a clean slate, or it gives you an extra day to get some help from the LAs or myself or on Piazza. Right? So that's where you should be. If you haven't already started on the implementation, you should definitely be focusing on that for the next 3 days. The other thing that I'll point out is after we come back from the break, you got the first 3 for free, right? You're going to have to schedule the rest of them. You now know how you work, whether or not it's been successful, whether or not you want to change it. Go ahead and schedule the rest of your semester using this Gantt chart if you're so inclined. But otherwise, this is the last time that this is the last week that I'll probably refer to the Gantt chart. Because at this point you're either doing well and you're self-organized enough that whatever you're doing is working for you, or you might be past the point of no return. Right? So let me go ahead and get rid of that, and let's remind ourselves of where we were last time here. All right. So we were trying to do some data projections. All right. Remember, we are online, so if you have any questions, go ahead and post to the YouTube live stream here. But basically, a projection is from a higher dimensional space down to a lower dimensional space, where you take a cube and you crush it down to a square, right? You're taking a 3-dimensional object and you're putting it onto 2-dimensional space. You lose one of those dimensions, one or more of those dimensions, because if you take a square and you project it down onto 1 dimension, you get a line segment. If you project that down onto a 0-dimensional space, you get a point. But with respect to data, you also want to aggregate that data so that you can produce more information. For example, how many games has each publisher published? We'll get to that in a second. Let's go ahead and look at an actual example here. This is what we were looking at on Friday. So we've got a whole bunch of books here, right? Books, title, author, and number of copies. We've basically got 3 dimensions. We've got a cube here. And I'm going to go ahead and crush that down to just 2 dimensions. One of those dimensions will be brand new. What I want to do is I want to group these by all the authors. I want all the Norman Mailer books together, all the Douglas Adams books together, and all the Orson Scott Card books together. And I want to aggregate all the number of copies. In other words, I want to know that there are a total of 13 Norman Mailer books in my collection, that there are a total of 7 Douglas Adams books and 7 Orson Scott Card books. So the first step to do that is to group it. So you group by the author. That sorts, now internally it doesn't actually sort them, this is just a visualization of how it works. You're putting all the Norman Mailer books together, all the Douglas Adams books together, all the Orson Scott Card books together. And then you crush it so that you are grouping all the Norman Mailer books together and then crushing it down so you just have Norman Mailer. You lose that 3rd dimension. You lose this title over here, just like you lost one of your dimensions. But we retain the author dimension over here, and then we aggregate all those values together by summing them up, so that we're left with something that looks like this: 13, 7, and 7. Okay. Now before I start developing that query, let's go ahead and take a look at the video game database that we've been looking at so far. Remember that we've got this game table, platform table, and publisher table. And what I want to do is I want to determine how many games each publisher has published. We haven't talked about joins yet, which we'll talk about next. So what I want to do is I want to focus on this table right here. I want to select out all the game information sorted along the publisher IDs. So let's come over here. I'm already using my database. So let's go ahead and first of all select everything from game. And let's take a look at that data and see what it looks like here. It's completely unordered, it's completely unsorted, it is not grouped at all. So what I want to do is first I want to group them by their publisher ID. Right? So let me add on a group by clause. Group by publisher ID. Right? And when I do that, I get a result that looks kind of like this. Right? So Lego Star Wars, publisher ID 1, Legend of Zelda, publisher ID 5, that's Nintendo, et cetera, et cetera. Now, am I getting a count of the number of games? I've actually lost data. Remember, I'm just doing a projection. I'm taking that cube and I'm projecting it down onto two spaces. I'm just getting a square now. I didn't actually aggregate anything together, right? So I'm selecting everything and I'm getting something, but it is not what I wanted. If I wanted it to actually group by this stuff and then count up the number of things that were in there, let me go ahead and go back to that original. What would that look like? There we go. What I would end up doing is I would end up sorting it by the publisher ID, so that all these ones are together, right? There are 3 things that were published by LucasArts. There were 1, 2, 3, 4, 5 things that were published by Nintendo. There was 1, 2, 3, 4 things that were published by, looks like Rockstar Games maybe, right? So that's the data that I want to get out. My group by clause basically does what I just did. It will sort it by the publisher ID, but now what I need to do when I do the projection, I need to sum up the number of records here so that LucasArts has 1, 2, 3, so that Nintendo has 1, 2, 3, 4, 5. Right? To do that, I need an aggregation here. Right? So first of all, is it going to be a sum? Sum is, 1 plus 1 plus 1 plus 1. That'll work for that first one, 3. Right? But 5 plus 5 plus 5 plus 5 times is going to give me 25. Right? Now, is that the number of games that was published by Nintendo? No. So it's not a sum, it is you want to count the number of records in each one of these things. For now, I'm just going to go ahead and put in star here. Right? Let's go ahead and execute that query. Okay. Lego Star Wars 1 and then a count of 3. Does that jive with what we just saw with LucasArts? 3, 5. There's Rockstar Games with 4. Right? It seems like it's working. But let's clean this up a little bit. Lego Star Wars, did that appear actually 3 times? No, there were 3 other games, right? Over here, I was not concerned about retaining the title of Naked and the Dead or Barbary Shore here. I got rid of that dimension. So let's go ahead and do that over here. I'm going to go ahead and go with publisher ID and then the count. Only the things that are relevant to this query. So publisher ID 1, remember that was LucasArts. Right, 3. 5 is Nintendo. 5. Rockstar Game 4. Right. This is also not very satisfying. Count with an aggregate of star there. That's not really what it's doing. Let's go ahead and give that. What did we call this thing? As on, number of games. There we go. What would we call that? When I say take a column and call it by another name so that it's a better name for this query. It was an alias. Right, there we go. So now I've got the publisher ID and the number of games, and it looks good to me. Right? Remember that this is Ubisoft, I think, and they have Assassin's Creed, I think, right? Let's check it out. At the very end here, there, another section added Assassin's Creed published by Ubisoft over here. Okay. So it looks like it's good to me. The problem is, do those mysterious keys, 1, 5, 6, 8, 10, do they tell you who published that stuff? What the publisher actually is? 11, 12, who were they? I have no idea. That's what we're going to take care of here in a second. Before we do that, what if I wanted to change this so that, I was only considering games that started with G, right? So let me go ahead and run this query again, and let's go ahead and sort them by games. We've got a bunch of G's, M's, S's, T's, I don't know. We're not going to get many. Yeah, let's go ahead and go with G's here. There, G, GTA 1, 2, 3, and 4. Right? Now, how would I do that normally if I just wanted to restrict my query to just those 4 games? So restrict to only games that begin with a capital G. Right? How do I do that? Select everything from game. What kind of a clause do I put at the end? Where, right? Name is equal to G something. So how did we do this before? How do we match any character after the capital G? You remember the wildcard, the % here? That will match any number of characters, including 0 characters. If there was a game, for whatever reason, that was a single character named G or something like that, in a single game that was named G, then it would still match it. Right? But am I going to get exactly what I want out of this? Let me go ahead and try it. Come on. All right. It's taking forever. There we go. I'm not going to get any results here, because equality here is checking for strict equality. Does it begin with a capital G and have a % sign in the title? And there's no game like that. So what did we do instead? It's kind of like that thing. And now we're going to get those 4 games. Okay? Remember that. What I want to do now is I want to come over here and I want to try to do something like the following, like this. Right? So where name is like G and then wildcard. There we go. Let me go ahead and try to do that. Yeah, and I'm going to get a syntax error here, right? You have an error in your SQL syntax. Is there any more information on that? Check the manual. Just check the manual. All right. The actual error message here is telling me to RTM. We remember what RTM is? No? RTM is read the manual, right? Or RTFM if you want to be really emphasized on it, right? And that's the actual acronym people use, right? So why is this not working? Well, it's because the where clause occurs before any data projection. If you wanted to restrict this, then you need to restrict it before that you actually group it. You want to only select things that begin with the, right? The Hitchhiker's Guide to the Galaxy, or the Long Dark Tea Time of the Soul, right? That needs to happen before you group it, right? So let me go ahead and change it so that I put it up there. There we go. So now I'm only restricting it to that one game, okay? Or not that one game, but those 4 games, all right? Oops, sorry. From game, where, group by. There we go. There's the order. And let me go ahead and execute that now. So 6 was Rockstar Games, and they published 4 GTA titles according to my database. Right? That is how you can restrict it before you project. What if you wanted to restrict it after you project? Right? Let me go ahead and grab all this and put this down here and get rid of that where clause. Right? What I want to do is I want to know any publisher that has published, say, more than 2 games or more games, 2 or more games. In other words, I don't want these 4 publishers right here because they haven't produced that many games. Right? I might try to put in a where clause, where number of games is greater than 1, or greater than or equal to 2 if you wanted to do it that way. But as we just saw, that's not going to work, because the where clause has to happen before the projection. What if I took that and tried to move it before the projection? So does this column exist before the projection? Does this column, num copies, total number of copies, exist before that projection? No, right? Even though they had the same name. So this is not going to work. In fact, it's probably going to give me, unknown column, number of games in the where clause. I don't know anything about that. I only know something about that after you've done a group by clause over here. Right? So that's not going to work. Instead, I need to add it after, where number of games is greater than or equal to 2. But as we already saw, the syntax does not allow that. So we need yet another keyword here. Let me go ahead and erase where and put in having. Right? Having is for after the projection. The where clause is for filtering out results from your query before the projection. After the projection, then you can go ahead and use this, this column here, this faked out column. But you need to use the keyword having. Now let me go ahead and put that. Right? Now, those last three that only had 1 video game published, now they've been eliminated from the result set here. You can use them all in combination. Right? Here, let me go ahead and copy this and then copy the where clause down here from game, where, game like G, and I'm going to get those 4 Rockstar games there. Okay? If you change this so that I want all the Z games, I'm not going to get anything back, even though Zelda was in there, right? How many did that would only end up with one game, the Zelda, or maybe it's the Legend of Zelda. What was it? Maybe it doesn't even begin with a Z. What was it? No, Zelda 2, The Adventures of Link here, right? So this query is going to only end up with one game. When we project it down and get an answer of one game published by that Nintendo company, right, we end up filtering it out yet again using this halving clause here because it's only one game at that point. Okay. Let me go ahead and put this in the notes. And again, this isn't giving me all the information that I want. The actual report that I want is how many games were published by each publisher. Now, if I go back to the original, just this one right here. Nope, sorry. Let's see. Get rid of this, from game, group by publisher ID. There we go. All right. I do get a report that looks something like what I want. I want a list of publishers along with the number of games that they've published. But that ID there is not giving me all the information that I want. I want the actual name of the publisher, which means that I've got two different tables that I need to bring together. The first table over here is the game table that would have the number of games published by that publisher. But then over here, I have to go all the way over to the publisher table here to get their name out. Right? That means taking these two tables and squishing them together or joining them together. Okay? Let's take a look at an example here. Let's see, where am I? All right, there we go. So I've got a student table here with a bunch of students, Starlin Castro, Anthony Rizzo, Dale Sweem, and Ryan Sandberg. And then I've got an email table here. There is a one-to-many relationship here. As you've all experienced, you now have at least 2 or 3 emails that you have to manage, right? You're probably forwarding them to one email and handling it there or something like that. But we live in a world now when you've got a bunch of emails. One for work, that Gmail account, that throwaway account that you use to sign up so that you don't get spam, et cetera, et cetera. And we've got a similar setup here. Let's see, who do we have? Ryan Sandberg here has 2 emails. There's the foreign key 998 that refers back to Ryan Sandberg in this first table here. So what I want to do is I want to join them together so that I get a list of all their emails, something that looks like this. Before we look at the details of that, take a look at Dale Sweem. Does he have any emails over here? Nope. A one-to-many relationship can still be a one-to-0 relationship. One person can have 0 emails. They could have 1 email address. They could have 2 email addresses. They could have 3, 4, 5. They could have any number of email addresses that they want. So we still have Dale Sweem here. It's just that he's not going to show up in this table because there is no record over in that other table. Right? This is a join. I'm taking this table and I'm joining it to that table to produce this new table over here. Now, before we all move on and look at some actual examples here, I want to do some of the math that I was trying to do last time. So let A be a set. Does this? Yeah, there we go. And we're going to do it like this. I'm going to do some LaTeX embedded here. So A is going to be equal to, or actually, let A and B be sets. There we go. I'm going to let A, B, and C. I'm going to let B be 1 and 2. There we go. Now take those 2 sets and do an operation to join them together. If you're taking 235 right now, you might have seen this. It looks something like this. A times B. There we go. Anybody know from 235 know what that's called? That operation between 2 sets. That's a Cartesian product or a cross product, right? Why? It's a cross product, right? The cross right there. Or a Cartesian join in the context of databases here. So tell me what that set looks like. What's in that set? A bunch of pairs, right? You take each element in A and you match it up with each element in B. A matches with 1. B matches with 1. And C matches with 1. Likewise, what else do we have here? I should have gone in order there. Let me go ahead and go back. I can type however I want. A matches with 2, right? What else? B matches also with 2. And finally, C also matches with 2. Right? Doesn't matter how you write them. Why? Because sets are unordered collections of like elements. Right? That is called the Cartesian product. And you've seen this before all your life, right? Ever since grade school math. Here, let me show you. Math BB of R times math BB of R. There we go. There's the rendered LaTeX. Does that look familiar? You called this the Cartesian product. What is that thing right there? The Cartesian plane. X and Y. Ever wonder why you write points in the Cartesian plane as, say, X comma Y? Well, what are they? They're points in that Cartesian product. Right? X and Y, that's a point right there. Right? So all it is taking one set, the x-axis, and doing a Cartesian product with the y-axis, right? So that you get a set of points, and a point is a pair. There's just like A and B up there, but A and B is simplified. So now some questions here. What is the cardinality of A? Right? In other words, here's how you write it in math. These Sheffer strokes here on either end. It looks like an absolute value, but it's not. Right? In the context of a set, it is the cardinality of it. What is the cardinality? The size. In this particular case, what is it for A? How many things are in the set A up here? 3. A? 1, 2, 3. Right? What is the cardinality of B? Cardinality B in this case is 2. So, as a consequence, what is the cardinality of A times B? A times B is equal to what? 6 in this case. Did you count them all up? 1, 2, 3, 4, 5, 6. What's the relationship there? The first one is 3, the second one is 2, and therefore their Cartesian product is the multiplication of them. So in general, if you have, say, A having cardinality n and B having cardinality m, what is the cardinality of A cross B? Or sorry, I keep saying cross, but in LaTeX it's times. Sorry. So you tell me, what is it? If the first one is n and the second one is m, then it is simply n times m. Here, c dot. That's what you're used to, right? N times m, or nm. Right? Okay. So what I'm about to do is I'm about to take one set and one table, right? One set, one table, they're the same. And I'm going to join it up with the other one. To do that, I'm going to use the following syntax. So I'm going to select everything from game, join publisher. Right? Let me go ahead and execute that. Now, is that meaningful data, first of all? Just look at the data and tell me if it makes any sense. GTA 4 was published by LucasArts, and by Sony Entertainment, and by Square Enix, and by Sega. Does that make any sense? No. How many results did I get back? Let's count them. And this is where my bad math was from last time. Right? How many? 374, right? Where did we get that 374? Let me go ahead and select everything from game, but instead of everything, I'll just select the count. Let me do the same thing for publisher. There you go. So 22 and 17. If I just naively join those two sets together, that's the Cartesian product, the cross product. 22 times 17. Pull out your calculators and tell me what it is. 22 times 17. Oh, hey, 374, that looks familiar. What did I just do there, by the way? I used an entire database system as a basic calculator. You can do that, right? You can ask it, what is 22 plus 17, right? You can ask it, what is 22 times 17 plus whatever, right? and it'll come back with an answer. So you can use this big giant database management system to do simple math if you want to, or not, right? You probably don't want to do that in general. But 374, that looks familiar. What's that? 374, right? So just a simple join here is a Cartesian product. It's taking everything over here and matching it with everything over here. But that's not what I want. I don't want GTA 4 to be matched up with LucasArts and Sony Entertainment. Who do I want it to be matched up with? Rockstar Games. So where is that record? Right there, Rockstar Games. How do I know that that's the record that I want? Well, there's the publisher ID 6 in the publisher table. There's the publisher ID 6 in the game table. That's how I designed it. The foreign key matches with this publisher ID over here, right? So I'm going to go ahead and change this join, right? This is a naive cross Cartesian product, right? This is a cross join or Cartesian product, right? That makes no sense. Let's go ahead and change it so that you only join on the publisher ID. So select star from game, join publisher on publisher ID. Right. Now this will work in most instances, but it's kind of bad practice to do this because we've got two publisher IDs, don't we? We've got a publisher ID over here in the game table, and we've also got a publisher ID over here in the publisher table. Now, if you followed good naming conventions and your foreign keys match your primary keys, this will work, right? But if you didn't follow those conventions, or you just want to be absolutely sure, you can go ahead and be specific by saying that the game.publisher ID is equal to the publisher.publisher ID. Right? Now it's getting kind of long, so I'll go down to the, do the next row there. Right? So now let's read this. Select everything from the game table, joined over to the publisher table, on that publisher ID in the game table must be equal to the publisher ID in the publisher table. And now I'm only going to get the relevant values here. GTA 1, 2, and 3, and 4 were all published by Rockstar Games, Rockstar Games, Rockstar Games. If I ask for a count here, right, then I'm going to get something much, much less than 374. In fact, I'm only going to get 22. Why? How many games are in my database again? 22. I'm only getting the games that are in my database joined with their publishers. But I'm getting all the information on the publishers. I'm getting their name, I'm getting their publisher ID, I'm getting it twice in fact, and then I'm getting the game ID and the game name. Okay? So, some simplifications here first of all. You will be joining so much to so much to so much that you eventually want to use aliases even for your table names. So game as G, publisher as P. That allows me not to have to write out game or publisher over and over and over again. This is the exact same query, but it's going to be, and the exact same results, but I don't have to type as much. And if I've got 1, 2, 3, 4, 10 tables, right, I am going to want to use these aliases as much as possible. In fact, it's so common to do this, you don't even need to type as. From game G, I'm already automatically giving it an alias. Join publisher P on G.publisher ID equals to P.publisher ID. Again, exact same results here, but it's a little bit shorter, okay? Can we make it even more short? Yeah, there are some other ways, but that's all the further I want to go, right? That gives me every single column. Only select the columns you are interested in. Right? How do we do that? By not using the wildcard. I just simply want the game title along with the publisher title. So name, right? Remember that the name of the game is name and the publisher name is name. Is that going to work? Nope. Why? It's, if you can read that, column name in the field is ambiguous. We've got a column named name in one table and the exact same column in a different table. All right, we can disambiguate that by saying g.name and p.name. There we go. And then I'm only going to get the game name along with the publisher name. Right? All those internal keys are now gone. I don't really care about them. I just want to publish this report here. Okay. But that's still not satisfying because I've got name. Imagine if I were to write a program to pull out each one of these pieces of data as a string, right? And I asked, well, the name. Well, which one do you mean, right? That one or that one? There's going to be an ambiguity there, right? So let's also use aliases on this. As game title, as publisher name. Right? I'll be I'll be lengthy about it here. Game title and publisher name. Now that is a good looking query there. Right? Go to the next line here. Generally, when I go to the next line, of course, I indent 2 spaces here, but I also go ahead and break on the keywords here so that you're always beginning a line with the keyword. Right? That's just the style. Okay. Excellent. Now, how can we produce a report like we had before where we get the number of titles that each publisher has published? We need to use a join in conjunction with a data projection. Right? So I don't want the game titles anymore. I simply want the publisher's name. Okay? And I don't want once I've joined with them, I want to go ahead and group by something. Right? And I don't want the publisher's name. I want the count of something. I'll go ahead and leave it like that. So how am I going to group this, first of all? How would you group it? How did we group it before? What if I grouped it by name? Is that going to work? Maybe, maybe not. Which name do you mean? Right? How do you uniquely identify a publisher? Let's take a look at our database here again. Right? That little, zoom in on there. That little yellow thing, what does it look like again? A key. Generally, primary keys are what are used to uniquely identify records in your database. And so that's what we're going to group by. But we do need to say which one, so g.publisherID. There we go. There. Now what are we going to count? Let me go ahead and start with just count everything. Let's do that. That'll work, right? Generally, what you should do, though, is you should count something unique, right? Uniqueness in this case is going to be with g.gameID. Count up the number of unique games that are grouped by their publisher IDs. Publisher IDs 1, 5, 6, right? Now, how many games appeared in there? There's that game, there's that game, there's that game. And they're all unique because each one has a unique primary key game ID. There, same result. Except that, wait a second, is that all the publishers we have? So let's come back up here and select all of the publishers. Star, there we go. All right. I see a lot more publishers than that. For example, which is Westwood Studios there. Did you see them in that other report? I didn't. Let's go ahead and jump down here and look. Nope, I don't see Westwood Studios in here. Why? How many games have they published, apparently? 0. Right? I want them to appear in this report. I want them to appear in this report with a 0 next to them to show me that they are in the database, but they have no records in the game table. Right? Let's come back over here to our ER diagram. And I'll repeat a question that we had when we originally started with this database. Can a game exist without a publisher? Nope. It's a parent-child relationship here. How would you have ended up inserting a game record with a game ID automatically generated by the database, a name, but without a publisher? You can't have orphans. You have to have a parent-child relationship. A child cannot exist without the parent. So, can a parent exist without the child? Yes, in this case, Westwood Studios. Westwood Studios exists without having published any games. Okay? So, let's come back over here and rethink that what we were doing, right? This gives a good report, but does not include any publishers with 0 games, ... So we need to rethink what we're doing here. What order did I go in? I went from the game table, and then I joined onto the publisher table. So think about what that looks like visually. Here's the game table on my right, your left, and here's the publisher table on my left, your right, right? So this is what's actually called a left join because we read left to right, right? And hopefully I'm mirroring this to you. Sometimes I don't always get it right, right? From left to right, right? And if you're going to join that way, then tell me about the publishers. If I go ahead and join from the game over to the publisher, am I going to get any of those publishers originally in that first table? No. I'm only going to get publishers that have published a game. So let's reverse this. Let's start at the publisher table first. Select, I'll go ahead and copy this. There we go. From publisher, P, join game G. On, and then the order here doesn't matter. Why? Because A is equal to B is the same thing as B is equal to A. And let me go ahead and execute this now. I still don't get what I'm looking for. I still don't get those zeros. To understand that, I swear to you that we are going from left to right now. Right? We're starting at the publisher table and going over to the game table. Let me show that to you without the group by clause here. So let me go ahead and select everything from publisher P, join game G, and you can see that the publisher over here, that publisher information is now on the left-hand side. If you noticed before, it was on the right-hand side. I've got publisher ID and the name of the publisher, and then I've got the game table information right here. Okay? So it is actually working. It's going from left to right now, but I'm still not getting the values that I wanted. Undo, 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 undo. There we go. Right. I'm still not getting those 0 publisher games. To understand that, what we need to do is we need to come back to this example. Ryan Sandberg did not have any emails over, or sorry, no, it was not Ryan, it was Dale Sweem. Right? I think he was with the Cubs for like 2 years, and then he was immediately fired. Right? Then he went on to the White Sox, where he was also fired. Anyway, these are ball players and from Cubs. Right? All right, so Dale Sweem does not have any email address over here. Consequently, does he show up in this join table? Nope. How do we make him show up in this table? What we do is we do what's called an outer join. Right? An outer join is a little bit different in that it will end up with data that looks like this. There's 1122 Dale Sweem, just his last name here, but a null email address. Okay? Let's try that over here. Instead of going with just a regular join, what we're going to do is we're going to do what's called a left outer join, but usually you leave the outer out of it. It's going to be a left join. And let me go ahead and get rid of that stuff just for now. And select everything, just to show you how this works. Now we're getting back a lot more results here. Right? A left outer join means preserve records over here. If there's no record that matches with a record over here, that's okay. Just go ahead and preserve it. And end up with what values? Can anybody read that little tiny word there? It's NULL, null, missing. Sony Entertainment has not published anything in this database, apparently. Square Enix has not published anything in this database. Sega has not published anything in this database. And Westwood Studios, all the way down at the bottom, has not published anything in this database. Right? The difference here is the keyword left. You can do a left outer join. That is a keyword. You can do that. But again, why write many words when few words do? Right? So left join. Right? Select everything from publisher P, left join game G. In other words, preserve records. Preserve records from the left table. Right? This is how you should read it. Preserve records in the left table, even if they don't have a record in the right table. Right? And let's go ahead and return to our original report over here. There we go. Instead of selecting everything, I'm going to select the publisher's name and then the count of the number of games that they have. Group by publisher ID in the publisher table. So p.publisher ID. There we go. And let's see what happens now. Do you see a bunch of zeros now? I see a bunch of zeros now. Remember Sony Entertainment, Square Enix, Sega? They didn't publish anything. They still end up with this in this query, but now when I sum them up, count up the number of records, I end up getting a 0. Right? And that's the ultimate query that I was trying to get to today. Right? So this will preserve records, preserves records from the left table and treats null values as 0. Right? So that when I go to count up the game ID, right, then I'm going to get a 0 for that because null is treated as 0. That doesn't count. Right? What if I did something else? What if I tried this instead? Just count everything. Does that look right? Sony Entertainment, Square Enix, Sega. 1, 1, 1. Why am I getting a 1 now? Remember, in this original, how many times do you see Sony Entertainment? I see it once. Right? And so if you count that as 1, then it'll end up in your report as 1. You don't want to count the record itself, this row right here. You want to count game ID so that you get a null which doesn't count towards your tabulation. Right? Nulls in general are treated as 0. Nulls in general are treated as nothing when you're summing something up, right? Or counting the number of things. Right? So this one is wrong because you don't want to count the row, but the game ID. So let me go ahead and leave that one there. This one is correct, where we're going to go with g.gameID. There. And there is my query. Questions so far? So you might think, well, a left join. Is there a right join? Yes, there is. It's the same thing, but in reverse, right? So you start over here on the right-hand side, and you join over here to the left-hand side using a right join. How many folks in here read right to left on a daily basis? Maybe if your language supports that, right? There are languages that read right to left, but not usually, right? So yes, there is a right join. What would it look like in this case? Select that stuff from publisher P. I'll go from right join, and then I reverse these. Right. I'm just going in the opposite direction. That'll give me the same report there. Right? Exact same report, but who likes reading right to left? Anybody? I don't. There's one a case in which we're going to have to in a second here, but I don't usually do that. So very rarely will I use a right join, only if I absolutely have to. Right? Besides, it's just a left join, but going from, you just reverse the order. From publisher P over here to publisher and game, you just reverse them. Right? Why do that when you can keep it simple and read left to right? Okay? Now, let's go ahead and finish by create a query to flatten the entire database. Right? Return to a CSV file, right? i.e. produce a CSV file. A CSV-like file. In other words, I want to take all 4 of these tables, join them down together, and get all the records, all the data in this table, in this database, so that I'll dump it to a CSV file. In fact, that's the usual assignment one, or that's was the assignment one last year. I just dumped all this to a CSV file and gave you a CSV file, and then I had you produce these reports so that later on I could show you how easy it is to do in SQL instead of Java or Python or something like that. Right? Very, very similar to your actual assignment, the one this semester where you were doing weather data. Right? There was only one table, but it's the same idea. If you've got a bunch of CSV data, how can you process that data with just a programming language? You got to open the file, you got to process the tokens, you got to iterate through it multiple times, right? Versus if it's in a relational database management system, one single query and you are done. Very, very powerful. Right? Let's return to that CSV file though. Right? I'm going to start all the way at the left. publisher over to the game, over to the availability, over to the platform. How many joins is that going to be, by the way? 1 table, join, 2, join, 3, join, 4. 4 tables. How many things in between? 3 joins. So let's start over at the publisher table. Select, for now, I'll go ahead and select everything. From publisher P, join game G on P dot publisher ID is equal to G dot publisher ID. That's exactly what we just did. Right? Join availability A on. Now, how do I go from this table, game table, over to the availability table? What is their relationship? The game ID foreign key in the availability table should match the game ID in the game table. Right? If you're using good names like this, there's no guesswork at all. If it's the game table, what's the primary key? Game ID. And if you're joining to the game table, well, what's the foreign key called? Exactly the same name. Right? So A dot game ID is equal to G dot game ID. Join over to the platform table, P, on P dot. How do I go from the availability table over to the platform table? Platform ID, platform ID. Right? P dot platform ID is equal to A dot platform ID. Oops, there we go. Now there's a problem here. Do you see it immediately? Not unique table alias P. I had a publisher P and platform P. Can I use the same alias for 2 different tables? Nope. So I'll go ahead and go with plat here, right? And plat here. Come on. There we go. That almost looks like I'm there. Right? But do you see, say, what was it? Sony Entertainment represented here? Where's the publisher? Publisher ID, there's a name. Do you see Sony there at all when I sort it? Nope. So let's go back over here and change that. These were just regular old joins. If there's a publisher that doesn't have any games over here, right, then they're being lost in this. Left join, left join, left join. Now I'm going to get a whole bunch more data, including Sony Entertainment. They don't have any games at all. So everything to the right is going to end up being null. Right? Take a look at all of the unique platforms. I've got Game Boy, Mac, NES, PC, PlayStation, PlayStation 2, 3, Super NES, Xbox, and Xbox 360. Is that all of my platforms? Let's check. Select everything from platform. There we go. Is that everybody? Unfortunately, I think it is. All right, so fine. Let's go ahead and insert into platform. Actually, we've only got 1 minute left. So what if I had, I'll just ask this and then we'll continue it next time. What if I had a platform that had no games available on it? Like Steam Deck, it's so new that I haven't even put any games on it, right? Would that show up in my query here if I started way over here at the left? Nope. So here's the use case where you might also need to start up at the right and work backwards. Well, if you start up left and go right and go left, how do you take these 2 data sets and merge them together? So those of you in 235, how do you take 2 sets and merge them together into 1 set? What is that called? A U for union. Right? And that's what we'll do next time.